Hello, my name is Jack, and today I will be your guide to the difference quotient. We must first define the difference quotient. One such definition is that the difference quotient is a measure of the average rate of change over an interval. But that definition is terribly and insufferably boring, so instead we can just call it the slope, because that's what it is. Why is it the slope, you may be asking? Well, let me show you. We take a graph. We can make our interval 0 and 1, as I am drawing presently. We then have a y value that is also 1. On this interval, 0 to 1, we have the y value increasing 1, meaning our slope is 1. So, difference quotient is literally slope. Now we can discuss the formulas that relate to difference quotient. The first is f of x minus f of a over x plus a. The other, f of a plus h minus f of a over h. You may notice that the first formula bears resemblance to the slope formula, which you are so familiar with already. Now, the end goal of the difference quotient, canceling out all the terms in the denominator, which will make more sense once we go over some examples. Our first example is to evaluate this function using the first difference quotient formula that was provided. To do this, it is always pragmatic to first start with your formula. Actually plugging the function into the formula is where it gets a little more tricky. Now, we can assume that f of x is synonymous with y. And since this formula mirrors our slope formula, our y's would be in the numerator. If f of x equals x over x minus 2, that would be like saying x over x minus 2 is like y. Thus, we'd put it in the numerator, along with our a function. Fortunately, our denominator requires no change. Now that we've successfully plugged in, the question is now, what do we do with those nasty fractions in the numerator? Well, get rid of them, of course, and we do that by multiplying by a fancy 1. Now we have a much nicer expression where we can distribute the x and the negative a. Once we do that, we can combine all of the like terms on the numerator, keeping the denominator the same. Now we can factor out a negative 2 from the numerator, letting us cancel the x minus a in both the numerator and the denominator, giving us our final answer. We'll now move on to an example with the generally less preferred formula. We have to evaluate the difference quotient for x squared minus 4x minus 12. Here we are once again starting with our formula, but I decided to move it over just for clarity of work. Once again, plugging in is the more difficult task, but here all you have to do is take the a plus h and put that in every time you see an a in the original function. Sometimes this will be an x. Along with the formula, when you subtract f of a, that's simply subtracting the entire original function. Making sure you plug everything in correctly is undoubtedly the most difficult part, but once you do that, you can FOIL everything and distribute as needed. After that, you can cancel out any like terms in the numerator and factor out that h in the numerator too. Once we cancel that h from the numerator and denominator, which is the integral of difference quotient, and cancel around some other numbers, we finally have our final answer.